Hello everyone. In this lecture I shall discuss the job sequencing problems for two jobs and K machines. Okay. If we recall our earlier lecture, in our earlier lecture we have discussed the job sequencing problem for n jobs and two machines, or in general for n jobs and K machines. Okay. So in both the cases, the ordering time of the machines are known. The ordering of the machines are known, in which order of the machines the job are to be processed, and the processing times are known. Okay. Our objective was to find the optimal job sequence, means the ordering of the jobs that will minimize our time, right? Ordering of the jobs that will minimize our time, and the total elapsed time. We find the optimal job sequence, the total elapsed time, and the idle time of the individual machines. Okay. So now in this lecture our focus is on two jobs and K machine problems. Okay, two jobs and K machine problems. Here the ordering of the jobs are known. This ordering of the jobs are known, right? Here ordering of the jobs are to obtain, right? Here the ordering of the machines are known. Ordering of the machines are known, but here the ordering of the jobs are known. And likewise the processing time is known in both the cases. Here also the processing time is known. Here also the processing time is known. The difference is here the ordering of the machine is known. Here the ordering of the job is known. Right. Here what is the objective? The objective is we find an optimal path of processing the jobs, right? That minimize the idle time of the individual jobs, right? So consequently the total elapsed time will be idle time plus processing time of job 1, which must be same as idle time plus processing time of job 2, and which will be my total elapsed time, right? It will be my total elapsed time. Okay. So here we note that the moment along the line y is equal to x, I will tell it in the working rule. So before the discussion of the details of the working rule, let me to introduce myself. I am Professor Susanta Kumar Paikray, currently working as a professor in the Department of Mathematics, Veer, Surendra University of Technology, Burla, Odisha, India. Okay. So now let me to discuss the working rule here. So here the working rule says we take the horizontal and vertical lines. Okay. The x-axis and the y-axis, and this x-axis for your job 1 and y-axis for your job 2, and we mark this sequence with their processing time. We mark this sequence in proper scale. We may use the graph paper. We mark this sequence. Okay. The sequence of jobs, suppose it is given in the order of A, E, C, B, D, in the order it is given. It is suppose given A, B, D, C. Then we just make the blocks. Like this. In proper scale we make the blocks. Here it is for A, here it is for C, here it is for your B, and here it is for D. Okay, in that way. Now the common regions are shaded, right? The common regions are shaded. This is for A and A, so it is shaded. Now this is B and B, it is shaded. Now for C and C, it is shaded. Now for D and D, it is shaded. Okay. Now our intention is to move. We want to move from this point to this point, from origin to the final moment. So we encourage the diagonal moment, right? We encourage the diagonal moment. So we encourage the diagonal moment up to the last. Okay, we encourage the diagonal moment up to the last. At the same time, this crossing is not allowed. Okay, so that means either we may move like this, or we may move like this, right? So as I have told you, this diagonal moment along the line y is equal to x, along the line y is equal to x means both the jobs are under process. Okay, both the jobs are under process. This horizontal moment means job 1 is under process but job 2 is idle, and this vertical moment means your job 2 is under process, job 1 is under idle. So as far as practicable, we have to find the diagonal moment so that both the jobs are under process, which will minimize the idle time. Okay, so the working rule is like this. We draw two parallel lines as I have mentioned. Horizontal lines, x-axis indicate the processing time of job 1. Vertical line, y-axis indicate the processing time of job 2. And here, and we mark the processing time as I have told along x and y axis. Construct the rectangular blocks as we did it, right? And we shaded the region by pairing the same machines. Okay, pairing the same machines. Preferably we use the graph paper. If not, we take the proper scale to behave like a graph paper, right? So now, as I have told, the movement along the shaded region is restricted, right? Because both jobs cannot be performed on the same machine simultaneously, right? So now we draw the line from origin to the last as I have told. Encourage the movement along the line y is equal to x, making the line 45 degree along horizontal, along x-axis, 45 degree with horizontal, is not it? With horizontal. So now draw the lines. So while we draw the lines, we will allow the horizontal moment, we will allow the vertical moment, we allow the moment along x-axis, but it is being preferred. Horizontal moment means job 1 is under process, but 2 is idle. Job 2 is idle. And here job 2 is under process, job 1 is idle. Okay, now here both job 1 and job 2 are in process, so we encourage it. Then consequently the optimal path is that which minimizes the idle time for job 1 and job 2. That is by restricting the vertical and horizontal moment as far as practicable, right? And also the moment along the shaded region is restricted, right? So let us now discuss one example. Now the question is like this: solve the following 2 job and 5 machine problem with the given sequence of jobs with processing time, or otherwise use graphical method to minimize the time required for 2 jobs and 5 machine problems in the given sequence below. Also find the total elapsed time. As I have told you, total elapsed time means your processing time plus idle time of individual machines. And the sequences are as follows. The job 1 and the sequence it is given in the order of A, B, C, D, E. In this order it is given, and the processing time is known. It is 3, 4, 2, 6 2 hours. Okay, and for your job 2, the processing sequence is known. The sequence is B, C, A, D and E with the processing time is 5, 4, 3, 2, 6. So this is given. Now we have to solve it. So now coming to the solution, you consider the x-axis, you consider the y-axis. Okay, this is my y-axis. This indicates my processing time of job 2 and this indicates the processing time of job 1, job 1. Okay, so in proper scale I will just mark 3, 4, 2, 6, 5. Okay, so let it be my 5, let it be my 10. Proper scale must be there. It is my 15, it is my 20. In that way it is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. In that way, and accordingly here also in the same scale, this is say my 5, this is say my 10, 10, this is say my 15, and this is say my 20. In the proper scale must be there. So it is 1, 2, 3, 4, 5. 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. 1, 2, 2, 3, 4 and 5. Okay, now you mark in 3, 4, 2, 6. It is 3, 3 you mark it, 3, then 4 means it will come to here 7, then 9, 15, then here 9. Okay, then here 15, then here 15, then plus 2, 17, plus 2, 17. Okay, and here you mark it 5 plus 4, 9, 5, then plus 4 here 9, then plus 3 is 12, it is 12, then 2, 14, then 2 here 14, then 6, 20. Okay, so now you draw the blocks. So we draw the blocks here. So at 5, just you gently press the line and draw the blocks. At 9, you gently press the line and draw the blocks. At 12, gently press the line and draw the blocks. At 14, gently place the line, and at 20 you just place this line. So at 3 you have, this is the line at 3. At 3 this is the line, you draw this line at 3 here. At 7 you draw the line, at 7 you draw this line. At 9 you draw this line, then at 15 you draw this line, at 15 you draw this line, and at 17 you draw this line, at 17 you draw this line. Okay, then you just pair the regions, just you mark the regions here. It is A, B, C, D, E. It is A, it is your B, it is your C, it is your D, and it is your E. In this order it is being done. Then along job 2, B, C, A, D, E. It is B, C, A, D, E. You pair the same machines here, same jobs here. Here A and A, this is for A and A, and this block is for your B and B, B and B, and for your C and C, this, and for your D and D, this. We just shaded them, and E and E we just shaded them. Now we have to start at this origin point and we have to reach at this final point. Okay, so you see, since this is your 3, so up to 3, right, up to 3, if we move, then it will make 45-degree angle. So this moment there is no issue, because it is 3 and it is 3, it is a square. Now this moment must be the moment along the line y equal to x, so 45-degree along x-axis. Now this is 3 up to 5 here, it is 5. So we reach at 3 here. So now you think of 3 to 6, 3 to 9, okay, 3 to 9, 6. So here we have this moment, we have this vertical moment. Now we start at this. So here you see, we move up to 9. So it is my 9 minus 3 is my 6. Okay, so from 5 if we start up to 11, we don't have any issue. Okay, so up to 11, the vertical moment is encouraged up to 11, right? So at 11, we reach at 11 now. So here there is a issue. If we move further, then there will be a crossover along the shaded region. So up to this, we encourage the vertical moment. It is my 14 point now. So now at this 14 point, we have, what is the gap here? This gap is 15 minus 9 is 6. If you create a square with side 6, then here we have 14. So 14 plus 6 is 20. So up to this 20 line, so if you move along this, then this vertical line is fine then. This diagonal moment is fine then. Okay. So now we have to reach over here. We have to reach here in that way. So this is the horizontal moment. Means this is from 15, 20 minus 15. Okay. So this is actually this gap along the horizontal is 17 minus 15. So this is 17 minus 15 is 2 hours. So this is the horizontal moment. So job 2 is ideal here. But here at this point, here job 1 is ideal. Okay. This is a vertical moment. Job 1 is ideal. How long it is ideal? Job 1 is ideal for this is 1 and this is 2. This is 3 hours. 14 minus 11. 14 minus 11 is 3 hours. And here also likewise. Job 1 is ideal. Right? Job 1 is ideal. During year 3 to 5. 5 minus 3 is equal to 2 hours. Okay, 2 hours. Now coming to the ideal time for job 1. So ideal time for job 1 is 2 hours plus 3 hours. Okay, it is 2 hour plus 3 hour is equal to 5 hours. And your ideal time for job 2. So job 2 is ideal because horizontal moment is here is 2 hours. Okay, it is for 2 hours. Now the total elapsed time, what does it mean? It is processing time of job 1 plus ideal time of job 1. So that is equal to your processing time processing time of job 1 is 17 and ideal time is 5. It is 17 plus 5 is 22 hours. Alternatively, it should be same as processing time of job 2 plus ideal time of job 2. It must be same here. You see, processing time of job 2. You see, the processing time of job 2 is up to 20 here. Okay, and the ideal time is 2 hour. So it is 20 plus 2. It is 20 and it is here 2. So this is equal to 20 plus 2 is equal to 22 hours. You see, this must be same as this. Otherwise, somewhere there is a mistake. Okay. So the total elapsed time is here 22 hours. Right. And the ideal time for job 1 is 5 hours. And ideal time for job 2 is here 2 hours. Okay. So this is what the job sequencing problem for 2 jobs and K machine. So now coming to the summary, in N job and K machine problems, the ordering of the machines in which order the jobs are to be processed is known, processing time is known. We need to find the ordering of the job sequence. Okay, we need to find the ordering of the jobs. But here in 2 job and K machine problem, the ordering of the jobs are given and the processing times are given. We have to minimize the ideal time of the job. Okay, waiting time of the job we have to minimize. In previous case, the waiting time of job we don't have any control, right? In the previous case, we are concentrating on waiting time of the machines. We minimize that. Here we are minimizing the waiting time of the job. That's why the diagonal movement is encouraged. Okay, that is why the diagonal movement is encouraged. In that way we compare both the cases. Okay, now my appeal to all of you is that if you feel that this lecture is interesting and helpful for you, please like and subscribe to my channel, and it will boost my motivation to upload the subsequent lectures for your benefits. Okay, so thank you all. Have a nice day. Let us close this lecture here.